Hello and welcome. In this video, we're going to look at another example of current division in parallel. In this case, it says the total current, that's IT, that's at the beginning here, IT, is equal to the 454.1 milliamps. If the current through 4 of the resistors are, and they gave us all these values here, there's 4 different currents here. What is the current through the 5th resistor? So they gave us the current I1, the current I2, I3, and I4. They want to know what the I5 current is. And we know that we can deal with that through KCL. We can say that if we have IT, we can subtract what we know we lost down each of those branches. We'll take I1 out, minus I2, minus I3, minus I4, and that's going to be whatever's left over in the circuit, right? And that's actually going to be equal to I5. And so we'll use our Desmos here and we'll calculate that out. We'll say that they're all in milliamps, so we'll leave them in milliamps. We'll take our total, 454.1 milliamps, and we'll subtract out what they gave us, 124.8 minus 138.5 minus 169.3 minus 11.2. That's going to give us 10.3 out. So we expect I5 to equal 10.3. And since the other ones were in milliamps, this is also going to be in milliamps. And so when we look at this, we can say, well, this first one here had 124.8 milliamps. The next one had 138.5 milliamps, 169.3 milliamps, and 11.2 milliamps, and 10.3 milliamps. Right? And so when we look at this, 10.3 means that it has the smallest current. So we expect that resistor to be the largest resistance. It's going to be the biggest ohmic value that we have in the circuit. And 11.2 is going to make us the second largest resistor in the circuit. Right? And that means that since this I3 current is the biggest current that we have, that has to be the smallest resistor that we have because it's such a large current. So this is our smallest resistor, and these other two are going to fall in between that. This one being slightly larger than the previous, and this one's going to be slightly larger than the previous. Right, so we can kind of predict how large these resistances are just based on the currents that they have through them. Right, and let us know if you have any questions.